Dear Chairperson, ladies and gentlemen, I am honored to be one of the keynote speakers at this conference. Many thanks to the organizers for it. My name is Juha Karvonen. I have begun my wine growing experiments on the northern coast of the Baltic Sea in Tuusula rural municipality in Helsinki region in Finland in the 1990s and compared the growth conditions of my vineyard with those some single vineyards in other Baltic Sea countries and few Central European countries. The differences in growth conditions between them are clear but not as significant as commonly believed. Global warming has caused considerable changes in growth conditions, and these differences will likely decrease in the future. My presentation includes a short review of Baltic Sea countries and their history of wine and wine growing and wine usage, the minimum climatic requirements for wine growing, temperature differences between certain vineyards in the Baltics and Central Europe, and the effects of global warming. I also bring up how location, altitude and latitude and topography affects growth conditions. I have used degrees Celsius instead of Reaumur and Fahrenheit and used a base of 5 centigrades instead of 10 centigrades for calculating the effective temperature some of the growing season. The Baltic Sea, the Nordic Mediterranean, is bordered by 9 coastal states. Its area is larger than Germany. It is between latitudes 53 and 65. From the highest latitude, it is just 100 kilometers to the Arctic Circle. It is worth mentioning that an attempt has already been made to cultivate grapevines at the Arctic Circle, and the vines have survived. However, the growing season has been too short, and the accumulation of heat has been insufficient for the grapes to ripen, even though the daily temperature can occasionally exceed 30 degrees Celsius. The Baltic Sea coastal areas are low, ranging from 10 to 70 meters above sea level. They belong to the temperate maritime zone between the cold and subtropical zones. The Baltic Sea countries are old agricultural lands, and Finland is the northernmost agricultural country in the world. In the Helsinki area, winter temperatures can drop below 30 degrees Celsius, and snow depth may reach almost 1 meter. However, such winters have become very rare in this millennium. Fortunately, the colder the winter is, the thicker the snow cover becomes. If severe frost occurs before the snow falls, it creates challenges for all grape cultivation areas, as part of the root systems may freeze, weakening growth and yield. Before going to the effects of the climate change, I would like to talk for a couple of minutes about the history of wine use and wine growing history in the Baltic Sea area, because it has remained rather unknown. Wine has been known there for thousands of years. Because there were no grapes, wine was made from honey during the Stone Age. The tradition still lives on in Denmark and Poland. Grape wine was introduced by Roman merchants who obtained high-quality furs from the Nordic countries. Those furs were in high demand in the Mediterranean countries. Initially, trade was made with goods that included various grape products, wine vessels, and wine, of course. The oldest grape product found in Finland are from the 3rd century AD. Money was used here for payment just a few hundred years after the Roman Empire began minting coins. There are numerous coin findings from the Roman Empire in the Baltic Sea area, including Finland as far as northern latitude 63. It is uncertain if the fur buyers and wine sellers were Romans or Central European brokers. On the southern coast of the Baltic Sea, the earliest signs of vine cultivation are from the 12th century. The earliest wine growers were monks. They grew grapes in monastery gardens to make wine for the Holy Communion. In northern Germany's Burg Stargard and Latvia's Sabil, vineyards are from the 13th and 14th centuries, and they are still working. In the 1600s, on the northern coast of the Baltic Sea, grapes were not grown due to the cool climate. Rich people imported wines from Germany and France. Interest in Nordic vine cultivation had Linnaeus's student, Professor Per Kalm, from Turku University. He traveled to North America in the 1700s to find new crop varieties suitable for cultivation in state of Sweden, Finland, including vines. In the late 1700s, grape cultivation expanded in the Baltic Sea region to the castles and manors greenhouses. In this millennium, almost all Baltic Sea countries have joined the European Union's wine-producing countries, which encouraged hundreds of growers to try outdoor and tunnel vine cultivation. Now the vine cultivation area in the Baltics and Nordic countries is approaching 1,000 hectares, and the aim is to establish its own Baltic and Nordic wine culture. Various indices are used to assess the suitability of a site for viticulture. According to the Amerine-Winkler Index, the sufficient heat accumulation during the growing season for hybrid varieties and some Vitis vinifera varieties has been achieved in the Baltic Sea region in most years. The Hughlin-Schneider Index classifies growing conditions based on temperature accumulation and takes into account the long days of northern wine-growing regions. It allows for the calculation of the impact of day length at northern latitudes on growing conditions and the growing season. According to this index, the heat accumulation during the growing season in the Baltic Sea region would be sufficient for the cultivation of many Vitis vinifera varieties and most hybrid varieties, like the Amerine-Winkler Index. Other indices include the Cool Night Index, which classifies wine-growing areas based on the lowest night temperatures during the ripening period, and the Dryness Index, DI, which indicates the potential water balance of the soil. According to the Hughlin-Schneider Index, all locations belong to the climate class cool or very cool for viticulture. Using the Amerine-Winkler, Hughlin-Schneider, Dryness, and Cool Night indices, the Global Geoviticulture multi-criteria classification system for grape-growing areas has been formed. Based on these indices and Bauer's growing place requirements, it can be concluded that the growing season's length and many factors affecting wine growth are already sufficient in most locations along the Baltic Sea coastal area today, but the annual average temperature could be higher. The averages for the summer months of June, July, and August are sufficient during warm summers, as is the average temperature during the growing season. If climate warming continues as predicted and hybrid breeding produces rapidly maturing and cold-resistant varieties, viticulture could expand much further north. If population growth continues and the climate warms, all types of crop cultivation will have to move northward. Europe is a small continent which can be divided into north and south side of the Alps. This picture shows the Alps and the northern side of the Alps, where temperature measurements were taken. The area between the southern coast of the Baltic Sea and the northern side of the Alps belongs to a relatively uniform climate zone, west wind zone, where temperature differences between areas are not so big. The northernmost parts of Europe, such as Lapland, are a different matter. Distances are not as long as on the North American continent. For example, in Europe, the distance from Helsinki to Herlisheim-Prekolmar in Alsace is 1,200 kilometers, which is the same as from Helsinki to Norgam, which is the northernmost point of Finland and the European Union. but in Canada this distance would be relatively short. The temperature and humidity loggers shown in the picture were used for soil temperature measurements. These loggers were placed on the ground surface or buried 40 centimeters deep. They can be programmed to record soil temperature every 3 hours for a whole year. After a year, they can be dug up, and the recorded temperature data can be downloaded using a simple computer program. The loggers worked perfectly. The problem was sometimes to find them in the soil after a year, so they had to be well marked, and therefore 2 or 3 loggers were used at each location. Nevertheless, a few always went missing. Was the thief a mole in the soil or some other animal? Sometimes I found the surface temperature logger on a tree branch. Then I suspected the thief was a squirrel. For calculating the growing season's length, heat accumulation, and other climate factors affecting growth conditions, I used the measurements from National Meteorological Institutes. Years are not brothers. This is true in the table, which presents the variation in the annual average temperatures and other measurement results. Each year, there is a strong correlation between high heat accumulation, abundant sunshine hours, and high solar radiation energy. Interestingly, even though the annual average temperatures were relatively low in some years, the heat accumulation of the growing season could be high. On the other hand, during some long 200 days growing seasons lasting, the heat accumulation was quite low. From these observations, it can be concluded that the success of wine growing in the Baltic Sea coastal region is not so much depending on the length of the growing season, but by high heat accumulation, warm summer months, and plenty of sunshine hours, which are increased by the long days of the summer months. Under these conditions, it is already possible to cultivate fast-ripening hybrid varieties and similar varieties to those in the wine-growing regions of Quebec and Siberia, where the annual mean temperature is low but the summer months are hot. However, the growing conditions in these areas are not the same as in the Baltic Sea region, as they are located 10 to 15 degrees of latitude further south than the Baltic Sea region, and the length of the day and photoperiodism are different there. The climate warming in northern regions has been faster than in the south, and according to scenarios, it will continue faster in the north than in other regions in the future. According to statistics of the Finnish Meteorological Institute, Finland's climate has warmed by 0.4 degrees Celsius per decade over the past 50 years. This was also observed in this table of my own research. The climate warming can be seen in the shortening of the ice cover on lakes and little snow cover on the ground. In our vineyard, located in the Helsinki area, the thickness of the snow layer has varied over 30 years, from less than 10 centimeters to nearly a meter. In some years, the snow cover has been on the ground for only 2 weeks. In Helsinki, air temperature was only in 4 days under zero during the winter of 2019 to 2020. The number of hot summers has increased, summer temperatures have raised, heat accumulation has increased, and the growth cycle from bud burst to harvest has shortened by 1.5 weeks. The growing seasons have lengthened compared to long-term averages. At high latitudes in north, the growing season cannot extend in autumn as long as in Central Europe, because sunlight in north in October is no longer sufficient for prober photosynthesis. The temperature rising has accelerated the ripening of grapes in the north in the same way as in the south. However, the acceleration of ripening in the north is not as harmful as in the south. The Baltic Sea region's climate has warmed by about 2 degrees Celsius over the past 100 years. Since the annual average temperatures fluctuate year by year, The temperature changes should be examined as a 30-year average. In recent decades, climate temperatures have risen rapidly, and changes can also be examined over shorter periods. The accompanying table presents how much the annual average temperatures have risen, and the growing seasons have lengthened in the Helsinki area over longer and shorter periods of time. In the Helsinki area, the average climate temperature over a 35-year period has been 5.6 degrees Celsius. During the next decade, the average was 1.1 degrees Celsius higher than the 30 years average. In the following decade, the average climate temperature has continued to rise slightly, and the number of warm years has increased. In recent years, the previous year's record has always been broken. The temperature rises can also be seen in the lengthening of the growing seasons. Year by year, the threshold values for grapevine cultivation, presented by Winkler, Huglin, Bauer and others, have been slowly but surely approached. Here I want to highlight one of the exceptionally warm summers in the Helsinki region. The summer of 2018 was warm across all Nordic countries. Already in May, temperatures were unusually high. The air temperature broke the records of previous years. June, July and August were hot. This continued until September. Due to the warm summer, the grapes ripened already in August, and some had such a big harvest that part of it ended up in compost. In recent decades, the Nordic countries have had real heatwave summers when temperatures have raised to 35 degrees Celsius or higher on several days and remained high for weeks. It has appeared also tropical nights. The definitions of a tropical night and a heatwave are country-specific. In Nordic countries, a night is called tropical when the night temperature does not drop below 20 degrees Celsius from 9 in the evening to 9 a.m. morning. The meteorological institutes have warned about health risks of prolonged heat waves and high night temperatures. During such periods, indoor growth has slowed, wine's water demand has increased, leaves are browning, and decreasing of turgor is visible as the fraying of leaves, exactly as in south. In the figure you can see the observations. The Huglin index was 90% and the Amarin-Winkler index was 47% above the average from previous 65 years period. The growing season was over 3 weeks longer than the 65 years average. The average annual temperature, growing season temperature, number of days above 10 degrees Celsius, and hydrothermal index surpassed the averages from 65 years period, and harvesting began on September 8th. This study examined how the altitude of growing locations affects climate temperature. It is known that the growing season lengthens and the climate warms when moving from east to west or from north to south, while it cools when moving from lower to higher altitudes. In this study, the sites were Tuusula in the Helsinki area at 63 meters above sea level, Unterstalten in Switzerland at 1,150 meters above sea level, and Ålsgårde in the Copenhagen area at 60 meters above sea level. Ålsgårde was 550 kilometers south of Tuusula and Unterstalten 1,560 kilometers south of Tuusula. The results showed that the annual average climate temperature on the northern coast of the Baltic Sea in Tuusula was almost the same as in the vineyard in the Alps at over 1,100 meters altitude, and in Tuusula the summer months were warmer than in Unterstalten and Ålsgårde. From this, it can be concluded that wine growing in the Baltic Sea area at sea level has almost the same possibilities as it has 1,500 kilometers further south in the Central European Alps. In the following studies, I aimed to determine how latitudes and the altitude of the growing location above sea level affect soil temperatures at a planting depth of 40 centimeters. Studies on grapevine growing locations and conditions have mainly directed to climate temperatures, the topography of the growing location, textural characteristics, and soil structure. But the study of soil temperatures at the growing locations has been less emphasized. Climate and soil are in close interaction with each other. The effect of changes of air temperature on soil temperature is presented by a curve which shows that their impact decreases with depth. The curve is not linear but undulating. In the surface layer, from about 40 centimeters depth to 1 meter, temperature changes are faster and more intense than at greater depths. Below 1 meter, the temperature variations caused by summer and winter are smaller and slower. Significant change is at about 40 centimeter depth, which is the planting depth. It is deep enough protecting the root system in cold areas. This picture presents how much the climate and soil temperatures differ when comparing the temperatures of the Helsinki and Baltic Sea area with those of Neubrandenburg and Freiburg in Germany and Herlisheim in Alsace. In the Neubrandenburg area, located north of Berlin, vine cultivation is in the beginning. Freiburg, located a couple of 100 kilometers south of Berlin and known as the hometown of the famous Rotkäppchen sect, and Herlisheim Press Colmar, near Colmar in Alsace, are ancient wine-growing regions. The temperature differences between them are clear. Helsinki at the Baltic Sea is the coldest place, but compared to the German locations, the differences are not big. Herlisheim stands out on its own. The table shows that the annual average soil temperature at a depth of 40 centimeters is about 1 degree Celsius higher than the average air temperature. It can also be seen that the average soil temperatures at depths of 20 centimeters and 40 centimeters do not differ significantly from each other. In each location, the soil temperature remained above 0 Celsius during the coldest winter period, but in the Helsinki area this lasted for almost 3 weeks, whereas in Freiburg and Herlisheim it lasted only 2 days. These graphs illustrate how the climate temperatures of northern and southern wine-growing regions differed throughout the year. The growing season is known to lengthen as you move south at the same elevation above sea level. 1 degree of latitude to south increases the growing season by 2.4 days, and a 100-meter rise from sea level shortens the growing season by 4.1 days. Between Tuusula in the Helsinki region and the Herlisheim vineyard in Alsace, there are 12 degrees latitude difference. These curves show that Herlisheim's climate temperature at the top is warmest and Tuusula's at the bottom coldest. At each vineyard, the monthly averages were lowest in March, which seems to be often the coldest month of the year. At all vineyards, temperatures began to rise rapidly after March and peaked during the summer months. In Herlisheim, the highest monthly average was reached 1 month earlier than at the other vineyards. From the end of August to December, the temperatures in Neubrandenburg, Freiburg, and Herlisheim were quite close to each other. Tuusula's temperature curves went their own way. Based on the effect of latitude and the annual average temperatures, it can be calculated that Tuusula's growing season was 2 to 3 weeks shorter than in the comparison locations, and a change in the annual average temperature by 1 degree Celsius corresponds to a 250-kilometer shift in the climate zone in the north-south direction. Thus, if our annual average temperature rises by 1 degree Celsius, we will have the same climate as 250 kilometers further south. This can be seen already in Baltic Sea region. Little snow, shortened ice cover on lakes, and almost ice-free Baltic Sea in many years. This study compares the monthly and annual air temperatures of the Baltic Sea capitals to those of the Quebec City region in Canada. In Quebec, there are areas where wine growing and winemaking has been for 500 years. There the wine growing has been a matter of will. As shown in the curves, the winter months in Quebec City at the 46th latitude are much harsher than those in the Baltic Sea region capitals located at the 60th latitude. Temperature differences between capitals begin to disappear in April, and in each place's temperature peaks are reached in the summer months when the temperatures in Quebec City, Stockholm, and Copenhagen are rather close to each other. The temperature curves for Helsinki and Oslo are almost the same year-round. Quebec's temperature curve starts to drop rapidly in October. In Quebec, the average air temperature in January can be very low. The temperature can drop under 40 degrees Celsius for weeks, and there can be a couple of meters of snow. In Quebec, the annual average temperature is several degrees lower than in the Baltic Sea region. In Quebec, wine ripens quickly during hot summers, and in winter, under thick snow, it is as in an igloo during the heaviest frost. Quebec's example shows that sufficiently high summer temperatures are more important for successful wine growing than the annual average temperature or the length of growing season. For example, in 2018, the annual average air temperature in Saint-Hippolyte, Quebec was 4 degrees Celsius and high summer temperature. In the Helsinki area in 2018, the annual average air temperature was 6.7 degrees Celsius and high summer temperature. Then the Helsinki area had a record harvest. In 2020, the annual average temperature was a high 8 degrees Celsius, but lower summer temperatures. Then only 1/3 of the 2018 grape harvest was produced. This table shows year-round measurement results indicating that in Helsinki, as well as in Rapina and Pärnu in Estonia, soil temperatures at a depth of 20 centimeters stayed at or above zero throughout the winter, even during the coldest months of 2010. During the coldest winter months of January, February, and March, the average soil temperature differences between the municipalities were minimal, but in April, the soil in the Helsinki was colder than at the measurement points in Estonia and Latvia. This is due to the later arrival of spring on the northern coast of the Baltic Sea and the thick snow cover of that winter. After May, the differences evened out, but the soil temperatures in Estonia were a few degrees higher throughout the summer until the end of August. After that, the soil temperature differences between the municipalities decreased, but in Rapina and Pärnu, the soil remained quite warm even in December and January. In the same year, 2010, soil temperature at the depth of 40 centimeters were measured in Helsinki, Rapina, and Tervete, Latvia. The results are presented in the accompanying table. The soil temperatures remained above 0 Celsius the whole winter. During the coldest months, the soil temperature differences between these municipalities were less than 1 degree Celsius. Helsinki had the coldest soil temperature also in this depth. These measurements also show that the further south you go along the southern Baltic Sea coast, the warmer the soil is in winter and summer. 2 latitudes further south at the same elevation promotes soil warming in the spring and maintains it higher throughout the growing season. Encouragingly for viticulture, even in the Helsinki area, was that there was no soil frost at a depth of 20 centimeters in winter, and the soil temperature remained above zero at a planting depth of 40 centimeters, also during the coldest winter months. The table results show that the temperature differences between the topsoil and subsoil are surprisingly small, and that snow and soil together are good insulators in winter. Due to the insulating effect of the soil, temporary very high or low temperatures do not harm plant roots or seeds. An example of this is short-term fires, where seeds remain viable at a depth of 30 centimeters in the soil, even though the surface temperature rises to hundreds of degrees. Even prolonged winter frosts do not damage the roots of grapevines if the snow cover is thick. In the Helsinki area, there were hardly any temperature differences at depths of 20 centimeters and 40 centimeters, but in Rapina, the differences were more distinct. This is explained by the maritime climate of the Helsinki area, where the sea moderates the temperature differences between the air and the soil. Rapina is 200 kilometers from the coast, so its climate is more continental, with increases temperature differences between summer and winter months, which are also reflected in soil temperatures. In this study, the soil temperatures of vineyards located at sea level on the Baltic Sea coast and at an altitude of 1,100 meters in the Alps were compared. The effect of latitude and altitude above sea level on vineyard soil temperatures was studied in the same municipalities Tuusula, Ålsgårde and Unterstalten as in the studies of climate temperatures. In the soil temperature study, temperature loggers were placed at a depth of 40 centimeters. The measurement results show that the annual average soil temperature at a vineyard located over 1,000 meters above sea level in the Alps was almost the same as the soil temperature at Ålsgården, which was in north 32 meters above sea level. In the summer months, the soil temperatures at Ålsgården were higher. Further north in Tuusula, soil temperatures remained significantly lower than in other locations during all measurement periods. It can be seen that the annual average soil temperature at planting depth was about 1 degree Celsius higher than the climate temperature, and soil temperature changes occur more slowly. As the climate warms, wine growing is predicted to move to higher altitudes in southern Europe, but because the mountains run out, cultivation will have to move further north. In this picture, it is shown how the increased air temperature has raised the soil temperature and shifted the soil temperature classification toward a warmer direction in southern Finland as well as in other Baltic Sea countries. The picture also compares vineyard soil temperatures between studied vineyards in Alsace, France, Germany, and Estonia. Soil temperature is expected to rise less and slower than air temperature, and the annual average temperature of the topsoil is estimated to be only 1 to 2 degrees Celsius higher in 100 years, even if the global surface temperature rises by 4.8 degrees Celsius. According to the soil taxonomy system, which is used in soil temperature classification, the coldest Pergelic class represents permafrost soil unsuitable for cultivation, and the next coldest Craic class represents soil suitable for agriculture, but where the cold significantly limits plant production. The northern areas of the Baltic Sea coast have belonged to the warmer frigid class, where summer temperatures are higher than in the Craic class, and the southern areas to the even warmer Mesic class, which has been favorable for viticulture. A large part of the Baltic Sea and Central European countries belong to the Mesic class, although there are significant differences between them, mainly due to altitude and soil composition. However, they do not belong to the warmer thermic class, where the mean annual soil temperature is 15 degrees Celsius or more. The figure shows that the measurement sites in Than in Alsace, Freiburg in Germany, and Rapina in Estonia belonged to the Mesic class. In the Helsinki area, the classification has varied, but in recent years it also seems to be stabilizing in the Mesic class, meaning that the soil temperature rise has expanded the wine-growing area to north. Here are the results of a study on how various coverings affect the annual average subsoil temperature of a vineyard. Commonly in cooler regions, coverings are used in grapevine cultivation. They protect the base and roots of the vine from frost damage, increase the length of the growing season, keep the soil temperature elevated for longer, and moderate soil temperature changes. Similarly, in hot areas, coverings protect the roots from heat. There are many types of coverings, but in cold areas, the best covering in winter is a thick snow and soil. So snow is not the wine grower's enemy, as some may think, but a friend. Snow itself is a good insulator because the snow cover also contains insulating air. Coverings can increase the protective effect of snow. In cool areas, black plastic films are used in spring and summer to increase soil temperature. This study compared the effects of black plastic foil, greenhouse plastic foil, grass-covered vineyard soil, and completely bare vineyard soil on soil temperature over 1 year. Under the black plastic film, the soil temperature remained higher than under other coverings compared to bare vineyard soil. The study also found that soil temperature drops a couple of months slower than air temperature, giving the roots more time to adapt to winter. A side finding was that planting next to a wall, which is generally recommended for hobby wine growers, did not increase soil temperature. On the contrary, the southern building was the coolest place. The explanation could be that the stone basement of a building keeps the growing place cool in summer and cold in winter. In the next two figures, I want to summarize the key messages of my presentation. The Baltic Sea and its coastal areas is 20% of Europe's land area. It is a large area where it is enough place for the future wine growing. The temperature differences between the southern coast of the Baltic Sea and the area north of the Alps are quite small at the same elevation above sea level. Vineyards in mountainous areas have rather similar growing conditions compared to those near sea level on the Baltic coast. The Baltic coast has longer daylight hours during the growing season, which compensates for the shorter duration compared to Europe's high-altitude wine-growing areas. Alpine vineyards receive sunlight later into the autumn because the Baltic Sea regions get too little daylight after September. Most of this region falls under temperate or cool climate classifications for grape growing, with Helsinki classified as a very cool region. In the near future, climate warming will move grape growing higher into the mountains in Central and Southern Europe and to the Baltic region and Northern Europe. It will allow for the cultivation of both hybrid and pure Vitis vinifera varieties. In Northern Europe, air temperatures have risen rapidly and the growing season has continually extended. In these regions, warmer soil reduces frost and the root damage risk in vineyards. The climate of the southern coast of the Baltic Sea region and north of the Alps forms a unified belt of westerly winds. The climate differences between northern and southern localities will probably decrease according to numerous climate scenarios. Thank you to all our listeners. A special thanks to everyone who allowed me to take temperature measurements in their vineyards and assisted with recording the data. Making measurements at the same time in different parts of Europe would have been impossible without their invaluable help.